So our next chapter is two-port network. So what is port? It is a pair of network in which current may enter or leave the network. Okay, so it means that suppose we have a network and in this network we have a pair of node. So we have a pair of node and the current entering in this network may leave the network, that is current enter from this node X and current leave the node leave from node Y. So the current enter from one terminal may leave the current from second terminal, so that the net current entering the port is equal to 0. Okay, so the net current will be equal to 0. So in two-port network we have a pair of port, one is for input and another one is for output. So this is our output port and this is input port, and the current entering in output port is I2 and current leaving the output port is I2. So the net current will be equal to 0. This is your network. So type of two-port network are so there are four major type of two-port network that are impedance, admittance, hybrid, and transmission. Okay, that is ABCD parameter which we have seen in power system. So here we will take input voltage as V1 and output voltage as V2. So we have input voltage V1 and output voltage is V2. Now to demonstrate this, we will assume and or non-zero initial condition. Okay. Now we will start from our first type, that is admittance parameter. So we have an input port that is AB and output port is CD. So we will assume here that the network is linear and contain no independent source. So the principle of superposition can be applied. Principle of superposition can be applied to determine the current I1 which can be written as sum of two component. One is due to V1 and one is due to V2. And another is due to V2. Now, using this principle, we can write I1 is equal to Y11 V1 plus Y12 V2, where Y11 and Y12 are the constant of proportionality. Okay, and similarly we can write equation for I2 also. So equation for I2 will be this will be Y21 into V1 plus Y22 into V2. So these two equations describe the two-port network. This is one, this is the second equation. So we can write this equation in the form of matrix that will be I1 and I2 should be equal to admittance matrix, that is Y11, Y12, Y21 and Y22 into V1, V2. Here the constant of proportionality is called Y parameter, that is Y11, Y22, Y12, Y21 and Y22. Okay, these are the constant of proportionality. So the constant of proportionality are called Y parameter. Constant of proportionality is called Y parameter. If this parameter are known, then the input and output operation of the two-port network will be completely defined. Now to determine this Y parameter, we will follow few steps. To determine these parameter, following steps need to be followed. Okay, so here step number 1 will be step step 1, connect the current source I1 in the input terminal or to port 1 and short circuit port 2. Now first we will connect the current source in input port, that is AB, and our output port should be short circuited. This should be short circuited, and we will connect input port. We will connect current source in input port, that is I1. Okay, this is I1. Now find V1 and I1 and calculate. This will be step 2. Step 2, find V1 and I1 and calculate Y11 and Y12. So Y11 will be I1 by V1 and V2 will be equal to 0. See this equation. Y11 is I1 by V1 if V2 is equal to 0, and Y12 is I1 by V2 if V1 is equal to 0. Okay. So Y11 is I1 by V1 when V2 is equal to 0, and sorry, this will be Y21. Okay. Y21 and Y21 will be equal to, see this equation, Y21 will be equal to I2 by V1. Okay, I2 by V1 when V2 is equal to 0. Okay, I2 by V1 when V2 is equal to 0. Okay, so we have put here the second terminal is short circuited, that's why V2 will be equal to 0. Okay, and there will be current in the second port, and we will write the equation of Y11 and Y12 by putting V2 is equal to 0. So we obtained Y11 and Y12, these two parameter, by short circuiting output terminal, right? By short circuiting output terminal. That's why these two parameter is called short circuit input admittance. These two parameter Y11 and Y21 is called short circuited input admittance. Now in step 3, we will repeat the process here by short circuiting input port and connect current source at output port. Okay. So we will short circuit input port, that is AB, and we will connect a current source I2 at output port. Okay, now here V1 will be equal to 0 and this will be V2, right? Now we need to find I1 and V2. So in step number 4, find V2 and I1. V2 and I1 and then calculate Y12 and Y22. Okay, see here, if V1 is 0 in these two equations, if V1 is 0, if this is 0, then what you will get? Y12 and Y22, right? So if V1 is 0, we will find these two parameters, that is Y12 and Y22. So what will be Y12? Y12, that will be equal to I1 by V2 at V1 is equal to 0, and Y22 will be I2 by V1 at V1 is equal to 0. So Y12 is called as short circuit transfer admittance okay, like we have seen here. Y1, okay, this is, let me correct this. Y11 is called as short circuit input admittance and Y12 or Y21 is called as short circuit transfer admittance. Okay, so please correct this one here. Y12 is short circuit transfer admittance and Y22 is short circuit output admittance. Collectively, the Y parameter are referred to as short circuit admittance parameter. Okay, this Y11, Y12, Y21 and Y22, these parameters are called as short circuit admittance parameter. Just take an example. Suppose we need to find admittance parameter in T network. Suppose we have a network, we have a T network. This is 2 ohm, this is 4 ohm and this is 2 ohm. Current, input current is I1 and here current in output port is I2. The voltage across input port is V1 and the voltage across output port is V2. Okay, now to find admittance parameter Y11 and Y21, first to find parameter y11 and y21, we need to short circuit the output port and apply and provide a current source in the input port. Okay, so in first step we need to short circuit the output port. This will be I2, and short circuit the output port, so this will get short circuited, and provide a current source in input terminal I1. Okay, so step 1 is done. See, step 1, connect a current source I1 to port 1 and short circuit the current short circuit port 2. Okay, so we have completed our step 1. What is step 2? To find I1 and V1. So I1 will be V1 by 4 plus these two will be in parallel, so this will be 2 into 2 by 2 plus 2. Okay, so this will be V1 by 5, right? And Y11 will be I1 by V1 at V2 is equal to 0, right? So this will be V1 by 5 by V1, which give you 1 by 5. Okay, and the unit is Siemens S. Okay, I mention here constant probability is called Y parameter. This is the constant proportionality with unit of Siemens. Okay, this I represent with S. Okay, so this will be V1 by 5 divided by V1, which is equal to 1 by 5 Siemens. Now we use here current division rule to find current I2, right? So minus I2 by using current division rule. Minus I2 is equal to I1 into 2 divided by 2 plus 2. Okay, so this will give you I1 by 2. Okay, and what is I1? I1 is V1 by 5, right? So this will be V1 by 10. Okay, so we got minus I2. So what is Y21? Y21 will be, see, I write here equation first. Wait, I1 is equal to Y11 V1 plus Y12 V2, and I2 will be Y21 V1 plus Y22 V2. Okay, so Y21 will be equal to I2 by V1 at V2 is equal to 0, right? Here V2 is equal to 0. So this will be I2 by V1 at V2 is equal to 0. So Y21 is equal to minus 1 by 10 Siemens. Now we will repeat the process to find Y22 and Y12. So step 3 will be to provide current source at port 2. This will be I2, right? So we will provide a current source at port 2 and we will short circuit this terminal. Okay, Now this is V2. Now I2 will be V2 divided by total resistance, that will be 2 plus 4 into 2 by 4 plus 2. So this will be V2 divided by 10 by 3. So this will be 3V2 by 10. Now Y22 will be equal to Y22. Okay, at this point V1 is 0, right? V1 is 0. So this Y22 will be equal to I2 by V2. I2 by V2 at V1 is equal to 0, and this will be equal to 3 by 10s. Now minus I1 will be equal to, with the by using current division rule, minus I1 is equal to I2 into 2 divided by 2 plus 4. This will give you 2I2 by 6, and minus I1 can be written as this I2 will be 3V2 by 10, right? So this will be 1 by 3 into 3V2 by 10, or we can write V2 by 10. So Y12 will be equal to Y12. So what is Y12? That is I1 by V2 at V1 is equal to 0. I1 by V2 at V1 is equal to 0. So this will be minus V2 by 10 by V2, which is equal to minus 1 by 10 Siemens, right? So the admittance matrix will be this is Y11. So Y11 is 1 by 5, right? Y11 is 1 by 5, Y21 is minus 1 by 10, and Y12 is minus 1 by 10. So this will be minus 1 by 10, this will be minus 1 by 10, and this is Y22, which is equal to 3 by 10. Into V1 V2. Okay, so similarly we solve all the question by using these steps. So we'll solve few more questions on this topic. You may get some typo here, so you can correct all this thing. Okay. We'll discuss few more questions in next video.